In the third section of Chapter 7 then, in trigonometry, we're going to talk about situations where we're trying to solve a triangle, but we cannot use the law of sines. The first two sections of this chapter dealt with the law of sines. In the first section, we learned that we can use the law of sines when we are given two angles and any side at all. And then in the section we just covered, which was called the law of sines ambiguous case, we learned that we could solve a triangle with the law of sines if we're given two sides and an angle that's opposite one of them. So the two situations where the law of sines can be helpful is if we have two angles and any side, because we can always find the third angle, or if we have two sides and an angle opposite one of those sides. Now, unfortunately, there are situations where we won't be given either of those two conditions. So we need something else. And what we need is something called the law of cosines. Now, the law of cosines can be used if we are given all three sides, but no angles at all, or if we're given two sides and what's called an included angle. The included angle is the angle between the two angles. It's where the two sides are between the two sides. It's where the two sides meet. So it is not opposite either of those. Now, with the law of cosines and the law of sines, we can solve any triangle there is. Now, the good news is the law of cosines is somewhat like an extension of the Pythagorean theorem. It applies, though, to all triangles, not just right triangles, so there is no ambiguous case for law of cosines. This is what the law of cosines looks like. And I think you can see why I said it's an extension of the Pythagorean theorem. This piece right here is what we generally consider the Pythagorean theorem. Now, the law of cosines, since it applies to all triangles, has this additional term at the end. If you are looking for an angle using the law of cosines, I tend to take the equation and I try to rearrange it so that it's solved for the cosine of the angle. For example, if I'm going to solve this bottom one for the cosine of A, well, the first thing that I would do is I would subtract the b squared and c squared. So I would have a squared minus b squared minus c squared would equal negative 2bc cosine of A. And then I would divide by this negative 2bc on both sides. And that would leave me with just a cosine of A on this side. And on the other side, I would have a squared minus b squared minus c squared divided by negative 2bc. So when I'm using the law of cosines and I'm looking for an angle, I rearrange it in this manner. And to tell you the truth, I actually divide a negative 1 through the top and bottom. By doing that, I end up with the cosine of A equals, now the bottom will just be 2bc, and on the top, dividing by a negative, well, that'll make the a squared negative, but the b squared and c squared will be positive. So the way I remember this arrangement is, whichever angle I have here, that's the side that's squared and subtracted on the top. The other two sides are used in both of the other positions, top and bottom. So this is what we will use when we're solving for an angle. And we're using the law of cosines. Let's take a look at a few examples. In this first example here, we're trying to solve an entire triangle, and we are given two sides, and since this letter doesn't match either of those, we have an included angle. Now, the first thing we'll find is we're going to find side A. And I'm going to set that up as a squared equals b squared plus c squared minus 2 times b times c times the cosine of angle A. And we're rounding to the nearest tenth in this problem. So I put in the square root of 20 squared plus 30 squared minus 2 times 20 times 30 times the cosine of 60. To the nearest tenth, I get 26.5. And we now have all three sides. So now let's find the angles. We're going to find angle B. And I'm going to use the law of cosines. It's a good idea if you start with the law of cosines to stay with the law of cosines. So I'm going to have cosine of B equals, and then on the top, I'll have my c squared plus my a squared minus, my c squared plus my a squared minus, and now I need my b squared divided by 2 times c times a. Now we actually end up using the inverse cosine. So I'll have 30 squared plus 26.5 squared minus 20 squared. All of that divided by 2 times 30 times 26.5. Now you'll notice that I included the whole top in a parenthesis and the whole bottom in a parenthesis. So for B, I get inverse cosine, and on the top 30 squared plus 26.5 squared minus 20 squared, all of that divided by the quantity, 2 times 30 times 26.5. I get 40.9 degrees. And then since we're trying to solve it, we also need the angle C. We know all of the angles inside of a triangle add up to 180, so angle C will equal 180 minus 60 minus 40.9 degrees. Angle C 79.1 degrees. And that's an example of the law of cosines. No ambiguous case, never two triangles possible, never no triangles possible. Example 2. Once again, it's the law of cosines. We have three sides. Let's find angle A first. The cosine of angle A will be equal to the b squared plus the c squared minus the a squared divided by 2 times the b times the c. And again, you're going to use the inverse cosine of, and on the top, 20 squared plus 18 squared minus 34 squared. On the bottom, 2 times 20 times 18. Once again, notice the parentheses enclosing the whole top and the parentheses enclosing the whole bottom. This time we're going to the nearest hundredth, so that's 2 decimal places. Inverse cosine, 20 squared plus 18 squared minus 34 squared divided by the quantity 2 times 20 times 18. 126.87. Okay, let's go ahead and find angle B. And again, I will stay with the law of cosines. If you start with law of cosines, it's best to stay with law of cosines. So the cosine of B will be equal to a squared plus c squared minus b squared divided by 2 times a times c. And once again, we're going to use inverse cosine. Inverse cosine on the top, 34 squared plus 18 squared minus 20 squared. On the bottom, 2 times 34 times 18. When I put that into my calculator, inverse cosine, 34 squared plus 18 squared minus 20 squared divided by, and then 2 times 34 times 18 to the nearest hundredth, 28.07. And finally, we need to find the last angle. And I guess that would be angle C in this case. I know all the angles in a triangle add up to 180, so 180 minus 126.87 minus 28.07. 180 minus 126.87 minus 28.07, 25.06. Law of cosines. This time we were given 3 sides, no angles, had to find all 3 angles. This last problem is an application problem, and it's an application problem where we have to use the law of cosines. Now it's a navigation problem. Since it's navigation, we'll begin with a north line. So I have a north line. And then our original path is 185 miles per hour at 120 degrees. Now straight to the right would be 90. So 120 degrees is going to be somewhere over here. So this is 120 degrees. And the magnitude of that is 185 miles per hour. And now we have wind acting upon this. So I'm going to draw a new north line right here at the head of this vector. There's my new north line. And the wind is in the direction 165 degrees. So 165 degrees, well, 180 would be straight down. So 165 is going to be not quite straight down. Now I made it considerably shorter than the green one. And the reason I made it considerably shorter is the magnitude here is only 32 miles per hour. Make that a little bit more legible for you. And now we're going to draw in the resultant. Just as we learned in an earlier chapter, the resultant is if you connect the beginning of the first one to the end of the last one. So this is our resultant. That's the path that our plane will actually fly upon. Now, in order to find that, I think we're going to need an angle in the triangle. So let's think about what angle we can get. The two north lines are parallel. So that tells me that this angle up here is going to be 60 degrees. And that's because same side interior angles are supplementary. Supplementary means they add up to 180. So 180 minus 120. Now, the way that helps us is a full circle is 360 degrees. So if I take 360 and I subtract 60 and I subtract 165, 360 minus 60 minus 165, I get 135 degrees. So that tells me that this angle up here is 135 degrees. And now we can use the law of cosines. We have two sides and an included angle. And that is the law of cosines. So x squared will equal 185 squared plus 32 squared minus 2 times 185 times 32 times the cosine 135. And we're going to the nearest tenth. So for the nearest tenth, square root 185 squared plus 32 squared minus 2 times 185 times 32 times cosine 135. To the nearest tenth, I get 208.9 miles per hour. That's called our ground speed. But it does ask us for our true course. The true course is going to be the angle from north all the way to our line of travel. So the angle from here all the way to there, that's our true course. So what we're going to do is we're going to find the angle theta. In the triangle. We're going to use the law of cosines. So the cosine of theta will equal, okay, now the 32 is opposite it, so I'm going to have to take the 185 squared plus the 208.9 squared minus the 32 squared divided by 2 times the 185 times the 208.9. And theta comes out to be inverse cosine, parenthesis, 185 squared plus 208.9 squared minus 32 squared, that quantity divided by parenthesis, 2 times 185 times 208.9. Theta comes out to be 6.2 degrees. But our true course is going to be 120 degrees plus 6.2 degrees, which is 126.2 degrees. That's the true course. And that's the law of cosines.